couple technical issues. One was getting the computer going, and the other was we had some construction going on, so we had to move a bunch of things. But you could hear us?
Yeah, we can hear you. You guys can hear us?
Yes, we can. Excellent.
Awesome.
So we'll give it over to Richard and you could introduce the show.
All right, thanks so much, Evan and Jordan, for joining us. So, Evan graduated from Stony Brook University from our MBA program, and so is Jordan. I believe he graduated from the engineering College of Engineering area. So their team have started using AI to and as part of their stuff. It's a perfect example illustrating how the combination of business students and technology students, how they can join force and create very interesting stuff. So Evan and Jordan, please go ahead and share your story with us. Thanks.
Yeah, absolutely. Richard, thanks for the background and, thanks for the opportunity and for everyone kind of being here today. I want to give a little background into who we are, kind of where we've come from and, what we've done. And then I'm going to hand it over to Jordan to kind of give more of a technical, talk on, how we're using AI in business, what that implementation looks like. And then we have some pretty cool demos set up as well. So I'll kind of get started. So, my name's Evan Gower. I'm joined along here with my partner and good friend, Jordan Rothstein. We both went to Stony Brook. I was a business and psychology undergrad class of 22, MBA school class of 23. Jordan, you were applied in mathematics.
Yeah, applied math and econ.
Applied math and econ. And so we met back in 2019. We actually both were on the rugby team at Stony Brook University. And when COVID hit, we came together as, two people who had, kind of always wanted to start a business. And so the first idea that we came up with was called Launchpad. And the idea of Launchpad was that we were combining restaurants' POS data with their marketing data into a dashboard for data aggregation to kind of give them a way to see our marketing campaigns on social media having a direct effect on sales. And so we worked on that for a bit until we kind of came up with the idea for Markata, which was a pivot from us from the original idea, but taking into this account, marketing data combined with these emerging technologies, specifically AI through machine learning. And so Markata was kind of a big start for us into really starting to build a company and building on this foundation of AI and of the lessons that we had learned, myself through MBA school and business school, and, have continued to progress since then. So the idea of Markata is that we connect businesses and influencers together for influencer marketing. So we built a web app and a mobile app. The mobile app is for the influencers to field offers from businesses, as well as some AI-powered tools such as caption writers, some data tools in there for them to track, growth and things on social media. And the web app is modeled after a Facebook ads or a Google ads, which helps businesses create campaigns, and then using our AI will help them write requirements and then connect them with influencers. So I'm going to go ahead and kind of share my screen here. And I'll give you kind of a little background before, handing it off to Jordan on who we are. So like I said, my name's Evan Gower. I specialize in the front end of business. I work, in the MBA school. I did psychology. So my focus is on digital marketing, things like advertising, UI, UX, and building systems. And I'm going to go ahead and hand it off to Jordan here for the rest of the lecture.
Cool. Alrighty. Thank you, Evan. And thank you, everybody, for joining us here and inviting us to speak. It's a great pleasure. So before I get started and go into a little bit more of the content, let me just first start by giving a little bit of overview of who I am and how we kind of got here. So as I mentioned, my name is Jordan Rothstein, and I specialize mostly here at Markata, working with backend, developing our database and really implementing AI in an effective way for businesses to kind of leverage it for their own needs. So as I mentioned, I was a double major in applied math and economics, and I started off my journey wanting to go to Renaissance Technologies, working in quantitative finance, and that's kind of how I taught myself how to program. Just a passion around quantitative finance. Fortunately, I didn't get hired there because I had a different position, which gave me a lot more time to begin collaborating with Evan and really come to my new passion, which I found was really entrepreneurship and, kind of leading the way in technology and using these technological like developments. Is like, as we're seeing today, AI is huge. It's a big buzzword, but what does it actually mean for business, right? Like a business can use ChatGPT to go in and, like write up an email for them, but how do you really leverage that technology to tackle bigger problems, more complex problems, and you really use the reasoning and the engine behind this AI to help businesses? So that's going to be kind of the topic of the lecture. On the next few slides, I'm going to go through, just an overview of some of the AI tools we use. I'll do a deeper dive into some of the specific, more technical components. I'll try not to go too deep into super technical behind it, but within the presentation, I've included some helpful links. So I think after the call, we'll send it over so you guys can do a deeper dive. And if want to keep exploring, I'm gonna pave that way for you guys. So I think, Evan, we could jump to the next slide here. Great. So the first thing I'm going to cover here are AI agents. So I'm just going to start with a question. Has anybody used AI agents? Have you guys heard of them? Anybody?
Seems nobody.
Nobody? Okay, cool. So AI agents are pretty much autonomous. So pretty much they're tools that you can speak to an AI and say, hey, send me an email. And what that AI can do is it can generate content based on context that you've provided. And it can be like, okay, now that I'll go and generate the email, it'll write the text for the email. And it can know, now that I've written the text, I then have to use, the Gmail API. It can then use the Gmail API and send that email over to, whoever the recipient is. So it really lets you complete multiple processes just through a single query. So like you can type, like send an email to evan@marcata.ai about our, Q1 results. And it could then, the AI agent will know, okay, I have to go look up my Q1 results. So it can go to a database, search for the Q1 results, formalize that in the text of an email, say, okay, now that I have the body of my email, I could then send it over to Evan and it'll just complete that whole process. So, right off the jump, you can see how it can simplify multiple tasks just through, sending one or just through like one simple search query. So as I have here, there's, multiple abilities for this, and AI agents is really the core of our, the technology behind our business, right? We try to use these AI agents to complete multiple tasks, and they're able to reason in the way similar to, to how like a human can. So they're super cool, super powerful. And, with the advent of, ChatGPT 4 specifically, they've become way more powerful as their ability to reason has, really kind of skyrocketed. And, yep.
So I understand the process of using like a Google API, logging in, and certainly you can make API calls to send emails, right? I also know how you can ask ChatGPT to do certain things, draft emails and whatnot. How do you integrate sort of the back end side of the process of sending the API call? I mean, I guess it actually will formulate the API call and everything for you and actually send it.
Yes, it can execute the API call, and later in the presentation, I'm going to cover a Python package in specific called LangChain, which helps us to do this. It's kind of what powers our most of our like AI systems. But yeah, it can formulate the API call and send the API call and manage that whole process.
So does it formulate it and then you send it on the back end after you get it, or does it actually have sort of superpowers?
It goes through the whole process. So it would be as if so like you're able to kind of define functions, and I can define a function. So like they're called like OpenAI functions, and I could define one that is execute an API call. So I'll just create a Python function that has the line of code to send that API call.
Okay, so it's gonna give you the input to your function, and then you have a process to execute it once you get that input.
Yes, yeah, exactly.
Because I was just a little concerned if we give AI too much power to actually, maybe it'll start, becoming web terrorists or who knows what.
Yeah, that's definitely a valid concern, and I know that like there are some like within there are like some GPT functions that can execute code, but it's not there yet as to where it can like actually like write that Python. So like I developed a Python function to send the API call, but I don't think GPT is there to complete that whole cycle. So we still have some more control over it.
Question. Are you guys creating the AI in-house or are you guys using third-party services like OpenAI?
So yeah, so very good question. So OpenAI is the engine that powers, the reasoning, pretty much like the reasoning behind our AI. So like what we do is we use, GPT as the core, and then we give it functions to execute certain tasks for us. So like we give it functions, to send an email or to search from a database, and it has the ability to, like understand a GPT. It can read, so pretty much it reads through like the doc strings of the function to know which one to use. So I got my function will have a doc string that's used to send the email. So then it'll look up which doc string best suits its need and then really execute that function.
And we're doing this as well, this isn't from like a standard chat GPT window. We were in it as developers, which is everyone can have access to it, but you get the added benefit of being able to do things like Jordan's talking about and pulling in the APIs.
Yeah, like so like to interact, we have a few different mediums. So I'll actually have a demo of a custom bot that we made that has a very bad UI, but we use it on our machines. But we use it in terms of like Slack bots, so we can kind of attach this so that if I mention a Slack bot, that like if I have certain, I can add it and I can tell it to do something, and then it'll execute that chain. Cool. So great question. So yeah, so this is just like an overview of like what our AI agents kind of yeah. So we talked through the abilities, what we do. So the abilities, we give it functions to use, we prompt it based on like the user input and then any prior knowledge that you want to give the AI. And then it has memory, so like these context windows. So
you have to do some kind of training, I assume, to get it to know, so it knows your system and what functions to execute.
Yeah, so it's training in the sense of us, like you have to. So I'll show you, like through LangChain, we have to give it the function. So like there's a certain way to like create this like LangChain, like they call them agents. Like there's a certain syntax structure to create the agent, give it the tools, and then kind of execute them and for it to know which ones to use. Cool. So with that, we could jump to the next slide here, where I'm going to talk a little bit about vector storage and, what is vector storage, how it's important, and, what is like really its use case for us and, in AI and in general. So, vector storage, if you guys aren't sure what it is, it's a very efficient way for storing data. So it takes, I would say like a SQL, so like a SQL database kind of to the next level. So for a SQL database, typically what I would go in is I would say, add this, so I'll have, let's just say I have, 2 column headers. One is, the time of day, and then the second header could be like the meal that I had at that time, right? So if I wanted to create a database of everything I've eaten, I would just say, okay, at 2 p.m., at 2 p.m. I had a sandwich, and I'd put that in and I'd add it. But what a vector database does is it's a way to kind of contextualize textual data, imagery data into vectors. And there's algorithms that do this. So it can pretty much take an image of like, let's say, at 2 p.m., I wanted to take an image of what I ate and I would timestamp it. I could then put that into a vector database, and it would store the same information, but what the vector does is it converts that image into a bunch of numbers, pretty much a vector that lets the computer then knows what it is. So there's different algorithms for how it converts images or text into vectors, which I'm not gonna cover that in specific. So what I'll be mentioning through the remainder when I mention vector storage, I'll say it either encodes or it embeds this text or these images into vectors. And I bet you're all wondering, why is it useful for us to have an image as opposed to just like inputting the text? And the reason is so one of the major reasons is, so then if we have all this data stored as a vector, we could then send it a question in natural language. The question could then be encoded as a vector, and then what we could do is use linear algebra, which is is huge in AI, huge in this stuff, and use linear algebra to determine which vectors are, have the shortest Euclidean distance between each other, and use that as a way to do like a similarity search. So if everything's vectors, right? All my images are vectors. I can then query like, sandwiches, right? And that'll be converted into a vector, and we can search through a vector database, and it'll output, like times that I ate sandwiches, for example. But the use cases behind this is way more than logging, what I ate. And I have actually a specific demo of using vector storage, but typically what we do here at on our team is we use vector storage for our for doing like semantic searches. So I'll have a demo later which illustrates this, but one of our major use cases of vector storage is for Markata. So as Evan gave like a brief overview of like what Markata is, right? We match businesses with influencers. And the way that we do that is we're able to leverage something like a vector search to determine which influencers will best fit that business. So when an influencer joins our app, they go in and they can set a description about themselves. So like if there's someone who's into, if they're a foodie, they like to go try unique food places, or if someone's into fitness or health and wellness, right? They can go in and write a brief description about themselves. And then what can then happen is when a business, so when a business has an influencer marketing campaign, right? In that campaign, they're going to describe what they want and what their product is that they want marketed, right? So then if we have a campaign for, like a nutrition brand, they can say, we want to promote like healthy lifestyle through these new supplements that we have, right? And using that query, we're able to kind of encode it and, perform the similarity search and figure out, okay, now which vectors in our database match closest to this to this campaign, like which descriptions of these influencers match closest to this campaign, and what as an output we then get those influencers. So it's really a way for us to kind of encode more complex information and query with natural language and things that might be a little bit more abstract. Whereas traditionally, if I have a database and I want to filter it, I would have to I have to know exactly what the column name is. I'd have to know everything that's inside that column, so then I can do the filter. So it's a way for us to kind of more dynamically query and store this information. So I have like a brief procedure here of kind of how it works, and I think I covered it a little bit in those examples, but a little bit more in languages. So the first step is we have our content, right? We have what we want to store in that database. What we do is we pass that through an embedding model, which converts that information into vectors. And what the vectors do is the vectors, are natural, or for the computer to understand what is the content that we shared it.
Can I ask you, so when you say vectors, I know you're purposely being a little abstract here, and I don't know, maybe you could give an example in a use case model, but you have to specify some kind of categorization that you're looking for or not, or is it just similarities?
Yeah, so the vector search is the only method that we use is based on for similarity. And so when I say vector, when it does this encoding, it outputs, it's like a two-dimensional array. I think the algorithm that we use, it's like a two-dimensional array of like 700 or it's like 700 rows by 2 columns, and that array represents the input which we fed it. So then there's like an algorithm to convert that there's an algorithm which converts that like text or an image into this two-dimensional vector.
I can understand, certainly I understand the image kind of proposition, what images are similar to this, and we can do categorization. So we train a model, we put a new image in, and it spits out odds of it being in a certain category. Certainly you have textual information. And I think you could do similar things like what are the odds it's about this and that. I suppose it's a lot more complicated to take do some training on some images and then a story about a cat and then say there's some similarities between those. But so you're putting in your use case, what data are you putting in exactly? I mean, you have some data on your customers and what kind of advertising maybe they do or what kind of market they're in, and then so, but you have some core set of data that you're training the model on, right?
Sure, and maybe I can take this kind of, in terms of what it looks like, when, like, for example, a business is going through, and maybe, I can kind of give a little bit more about the value prop as well that Marcata provides. And so, what a business is going to do is we have a preset, list of requirements, right? So they're going to put in their product, they're going to put in, what the promotion is that they want to sell. They're going to put in a brief description about what type of influencer or what kind of campaign they're looking to run. They're going to pick the time of day. They're going to pick their campaign runtime. If they're a location-based thing like a restaurant or a store, they're going to add in their location. And so all of that data is kind of combined together. And so, we're taking, something that you used to be a business is manually reaching out to an influencer, bringing it down into essentially a form, like similarly to how you felt like a Facebook or a Google ad. And we're using that data to kind of query this database. And maybe Jordan, you can get a little bit more technical than I.
Just one brief question about that. So now I can see how it would be easier to train if you would have sort of a multiple choice kind of thing or a numerical evaluation. Are you actually using natural language processing at that level, or is it like more objective data?
Yeah, so I'll say that, so to do this like embedding, we don't train a model that does it, right? There's existing algorithms that embed like images and text, and the different algorithms are better for different use cases. So like the one which we use, for this is an algorithm that is good for like semantic searching. So it's able to take in that input and really distill it into like its meaning, like what it means and what is like the essence behind it, and then converts that into the vector, which it stores in the database.
Okay, cool.
So there's different algorithms for different use cases, and then so like this, for this specific example which we're demoing, is like more for like a semantic search.
Right, and also, if I may, one thing very interesting about using AI in this application is that this business model has been around for many years. Basically, it's a marketing company trying to identify influencers that would be nicely fit for a particular audience. So using AI, they actually would be able to speed up this process drastically, because you can imagine that it's a matching problem, right? There are tons of influencers out there. There are many different other platforms. Yeah, using this type of tool, similarity search, powered by AI tool, they can actually speed up such a process very drastically.
Exactly. And that's kind of, one of the main, takeaways from this is, especially Marcata, right, is this ability to streamline business processes. And so in the example of Marcata, we do that with influencer marketing. Businesses are not manually searching for influencers. They're not, doing the cold DMs. They're not doing the reach out and everything themselves. We created a processes using these types of, systems to streamline that. And we'll talk a little bit more. We do have another company, To Something, where we're doing similar things, right? Using different types of algorithms, but the goal here is streamlining business processes using these technologies.
Cool. So yeah, great questions, and I think great discussion there. So I guess in the interest of time, we can move on to the next slide, where we'll talk a little bit more about, I'd say, another use case of vector storage, and something that is another tool which we use at To Something to kind of enhance existing GPT models. And that's called, retrieval augmented generation, also known as RAG or RAG. And what this is built off of vector storage databases. But what RAG lets you do is it lets you to add context to a model that it doesn't necessarily know about. So like the GPT models are kind of stuck in time, right? If I asked a GPT model, or let's say like if a GPT model doesn't have access to the internet, right? If I just asked one that has no access to the internet and said like, what was the weather today, right? It wouldn't know. It doesn't know anything about something that's like temporally dependent or anything that has happened like majorly past its training window. Right?
I did that on ChatGPT and it told me it didn't have that information.
Yeah. So what retrieval augmented generation lets you do is it lets you, so I will say it's an architecture. So before, it's not just like something like you just put in the tool, but it's like a way you'd have to structure your prompt, like your prompt cycle or your prompt like layout, what we call like our prompt engineering. But this architecture lets you add additional context to a GPT model, right? And pretty much so it's kind of, two phases. Or sorry, before I get into the technical specifics, let me just cover a little bit. I get too excited. I'll cover a little bit more about why we use it. So they're stuck in time. And LLMs don't have information on private data, right? So like if I'm at two something at a nice company, right? We have a whole Google Drive with hundreds of files that have information specific to us and our use cases. And if I said to ChatGPT, I might say, I asked a question about our business, and it might come back with an answer that's just totally wrong, right? And that's what we call like hallucinating, right? Sometimes these models try to reason their way through a problem based on the context, and they don't have the ability to say, I mean, sometimes they do. They're like, I don't know, but they'll try to. They want to try and get a solution. So that's what we call kind of our hallucinating. RAG helps us circumvent that problem. And the third piece is, training models is super expensive. So like ChatGPT came out and said, it cost $100 million to train the model behind ChatGPT, which is, I mean, a lot of money. So like to train another model, right, that has information up to today, like we don't want to spend another $100 million, but what we want to do is leverage the like the reasoning ability of the model and just let's give it new information. Let's give it that additional context. Let's give it a whole new database. Yep.
I haven't tried this, but maybe you know the answer. And maybe it's similar to exactly what you're saying. If I would go in ChatGPT right now and say, today it is sunny and 70 degrees Fahrenheit, and then the next thing I entered that, and then I said the next question was, what is the weather like today? Would it be able to take that information and essentially augment its knowledge?
Kind of. So that's kind of like with the context window. So like ChatGPT can only remember, I think it's like they do
tokens or something like that now.
Yeah, so like it might be like 128,000 tokens, which might be, let's just say, 10,000 words. It could be way more. I don't know. But what ChatGPT can do is yes, it can remember what you said. If I say it's like 70 degrees and sunny, and then I said, what is the weather today? I believe it will respond with the correct answer. But if I said to it, the weather today is this, and then I took the text from like a Lord of the Rings book and pasted it in, and that would probably exceed that 10,000 word limit. And then I asked it, what is the weather today? It would probably hallucinate because it doesn't remember, right? That you would have pushed that context outside the window. But what 8,192 tokens. But so what RAG lets you do is it gives the ChatGPT pretty much a vector storage database that it can use as its central source of truth. And it can query that database using natural language. So what the architecture would do is I would say, let's say it doesn't know anything about the weather. And then I type in, what is the weather today? Based on how we would set up the prompting, it would know, okay, I need to go look into my weather database, right? And that might store weather for the past, 100 years, right? And it could look up and figure out, okay, which vector is similar to today and kind of pull that specific information. But like the more a cooler use case of this that I've seen a lot online, a lot on Twitter is is really giving ChatGPT access to like documentation. So I can take, like I mentioned before, here we use this what's called LangChain to do almost all of our AI engineering stuff. And I could store all of LangChain's documents in a vector database, right? Can like chunk it up, vectorize it, and store it. Then when I ask ChatGPT, I'll be like, how do I do something like this in LangChain? It'll know that it has to go in, then use its storage database, query the correct vectors, contextualize that information, and then return it to me, right? So it's a way to circumvent this problem of LLMs having limited amounts of knowledge and kind of being stuck in time. And instances like if there's private data, right? If I at our company, right, Evan and I have so much data, we could put all that data if we wanted to into a vector storage database and query it and be like, hey, like what happened on this meeting on like October 11th? And I can go in and say, okay, let me search for the meetings and let me pull that information and feed it back. And the reasoning engine behind all this is like the GPT-4, but we just give it that additional context. We give it that source of truth. Cool. So I'll pause there. I'll just see, is there any questions with this framework? I know I didn't go like into the details about how we set it up, but just kind of wanted to like say high level of what it could do and you know, potential use cases.
It contains that context, I assume, and then every time you add a new document, you can update the context, is that?
Yeah, you just put it into the vector database. You'd encode it and put it in the vector database.
But it doesn't read the database to build the context each question, right? It somehow trains it in some way.
Or so it uses, so like similar to like before when I said like, you know, like if I did like the semantic search, right? If I'm looking up something, it'll put in the correct query to the vector database, like, because like it can know what it does, or it knows what it needs to find, right? So like if I need to find the meeting from like the GPT can reason to itself and say, I need to find information from the meeting from October 11th, right? Turn that into a query. Like you would tell it, you would say, we have this, part of the prompt is like, we have this database that has all of our information, all of our meetings and everything. And then that would be part of the prompting. So then it would go create a query for that database. So then pull from our vector storage, whatever answer comes out would then get fed back into the GPT, and then it'll say, now you have like the information from that, like, you know, you have the response from the query, like summarize an output or whatnot.
So it will get it from the, it takes the question, it recognizes the information it needs, it goes to the vector, grabs that information, builds the context around that chunk, and then answers the question based upon that.
Yeah, exactly. Exactly, and it's a specific, and it's like the RAG is the architecture to do that process, which I have here in the image on the right. It's like a little flow diagram of it, but yeah, that's exactly it. Cool, great. So the next thing, and this is something I'm super excited to talk about. It's one of my favorite Python packages, open source libraries. It's called LangChain. I actually had an opportunity where I was able to contribute to the code base just this past week and really update it to support GPT-4, which I was, you know, super excited about. So I'm sure you're all wondering, you know, what is LangChain, right? What can it do? And I'm going to give like another, when I do like the code demos, I will show, I'll go through like some of the structure of it, but pretty much LangChain is a framework to develop AI agents and really extend AI past that chat model, past that GPT window that you go in and, you know, type in like, give me a workout or something, right? It allows you the framework to extend it and apply it to business applications and, you know, like pretty much unlimited options on kind of what it can help you do. And LangChain offers a lot of great tools, and I would say the same. I don't work for LangChain. I'm not like trying to push their products on you guys. I'm just a very good advocate, and they're very, you know, they're big in this space. And they give a lot of great tools for developing agents and developing these AI applications. So, you know, they have different things such as templates. So like they have templates for retrieval augmented generation. So they have, you know, existing frameworks that you can go in and say, okay, here's my use case, right? I want to give my GPT model access to all of my documentation. Like, here's the template for that. And, you know, you can go in and you can go in and, you know, just change the inputs and put it to your documents. And then all of a sudden you have that model, right? So like we use templates a lot. We use it a lot for, you know, like for our use cases, right? We start with something that exists, right? It's always easier to leverage work and things that exist and then build from that, as opposed to like, I'm not going to go and research how do I implement like retrieval augmented generation architecture. Like I understand at a high level what it does, but that work of like, you know, doing that from scratch is, you know, it's a lot of effort. And they have these templates, they have these ways, like different templates for all different kinds of things. The other thing that LangChain has is something called LangServe. So it allows you to deploy, like if I create a custom agent for, you know, for like so like one of the demos I'm gonna give to you is we created an agent for writing tweets for us or helping us to write tweets, and I could deploy that to a REST API and give anybody access to it, or I can deploy it to the REST API and then add that API to my like an app that Evan and I have. The other thing that it has is something called Langsmith, and this is an amazing application that lets you debug these like LLM chains, these like agent chains. So like when I have these tools, right, I described in the beginning like an AI agent, and it does something, right? I tell it if it wants to write an email. The AI itself is communicating, like it says something, it has a thought, and it processes it. And Langsmith is lets you kind of lets you see those thoughts, and you could kind of see the reasoning steps that are happening in like your execution workflow, which super helpful in debugging these applications because they kind of are like a black box, right? If I go into ChatGPT and I ask it a question, I have zero idea of like how it got to that answer, right? It just it goes into, it thinks and gives it to me. But this Langsmith lets us kind of dive a level deeper and understand, and helps us debug in that manner. And then the fourth thing that I want to describe is LangChain decorators, and that's what I'll be showing to you in a second. But the LangChain decorators are really, I think, one of their coolest applications, and they let you kind of turn any Python code into an AI agent, right? You just have to add a decorator. I mean, there's like a specific syntax that you need, but it's very simple. But you just need to add a decorator to your function that says like, that tells the function, or it tells like the code that this function is a that it's or that like this code I wrote is a function that the AI can call, or it's a prompt that the AI can call. So I don't want to go too deep into that because I'll do a quick walkthrough of kind of what I've developed on it. But I guess, do you guys have any questions on LangChain, or should I jump right in to my demo?
Hopefully they don't decorate that function that launches the nuclear bombs.
Yeah, hopefully not either. I hope that's hidden somewhere. So cool. All right, yeah. So that was kind of the content that we wanted to cover, and I'm gonna go in and give two demos. So the first demo I'm gonna give is around a semantic search. So that problem that I laid out of exactly how we so it's a simplified version of kind of what our system does, but that semantic search to find influencers, and I can show you guys a little bit how that works. And then second demo I'm going to give is on our Twitter chatbot, so we can I could demo to that to you guys as well. But yeah, so I think Evan, could you stop sharing quick just so I could share? It wouldn't let me share. Sorry. All right, cool. Can you all see my screen? Oh, that's my chat. Can you guys all see this?
Yep.
Okay. So here's a Python notebook, and I will say, so I pushed this notebook into a GitHub repo that we'll send over in addition to this code base, but you can clone the repo. I added like requirements.txt if you want to try and get started and run this stuff yourself. But so the first step in our repo is kind of going to be defining, importing all of our packages. So we do that. We import our packages. Now here in this section, what I'm going to do is I'm going to define, 3 influencer types. So this is kind of the example that like I verbally explained, but we have 3 people that are on our platform, for example, or that have like signed up for our platform, right? We have Martha, who is a foodie, right? She likes discovering hidden gems in the food industry and so on. We have Billy, whose passion is, exploring the globe. He loves experiencing different cultures and their from their foods to their lifestyle. Then we have Joan, who is focused on improving their health and wellness. They want to share diet, exercise, and lifestyle tips. So the first step in doing one of these semantic searches is I take this and I put it into this influencer's data frame. So I can show you. Right, so we have our data frame where we have the name of our influencer, and then we have our description. So the next step is putting this into a vector storage database. So just really quick, what I'm using for the vector storage database is this package called FAISS, and it's very good if I want to do like in-memory activities. So typically, like our systems, like we have a Pinecone database that's massive, right? It can hold way more data than just like these 3 influencers, but this package allows you, it's very good for testing and debugging if you want to do like stuff in memory. So the first thing that you do is you want to extract our descriptions, right? So that's, who are Martha, Billy, and Joan. The next thing that we do is we want to encode these descriptions. So like I said, this is going to be embedding, right? We're going to be converting those descriptions about them into these vectors. And I'll show you what a vector looks like. It's just going to be a bunch of numbers, but just so you guys can, understand a little bit. So we encode it. We have to pass through the dimension. We create an index for these vectors, which helps us to search. We normalize the vectors and we add these vectors to an index. So if I run this, hopefully it works. Live demos are always okay, cool. A little green check mark. So we are good. But so if I show you vectors, right, and I give you the shape of vectors, it's going to be, it's 3. So 3 vectors, 1 for each influencer, or each influencer, and then it's, 768 numbers that are the semantic representation of that influencer's description, right? And it uses this algorithm to do it. It uses this, paraphrased MNet base v2. This is an algorithm you use for semantic search. Like I said, there's many more dependent on your use case. So now here we have our vector of numbers. And then the next step is going to be encoding a campaign description, right? So like Evan said, our application is a little bit, it's more complex in how we generate this campaign description. So we have more information around what is the company, what they do, and so on. But just for this example, it's just going to be like a sentence just about what the campaign is about. So I can add so I'll delete fun and we'll do a few examples here. So we have so the campaign description is a salad campaign. So we could assume that this is a restaurant, right? They're running a campaign about salads, which is a healthy option. So what we do is we take that description and we encode it. And this gives us our search vector. We normalize the vector. Hopefully this works. Good. And then now that we have our search stored as _vector, we're able to search through our index. So our index, remember up here, is our vectors of descriptions. We search through our vectors, and then we do this, and then I want to display the results. So if I run this, it'll display the 3 influencers in order of which one has the shortest distance. So I know I mentioned before that we talked about like the Euclidean distance, right? So we have all of our vectors, right? And the way the algorithm works is it finds which vectors are closest together in space. So using Euclidean distance, which is fun linear algebra stuff that I honestly thought I never was going to use. But here's a pretty cool application of it in real life. So we have, so Joan was the first influencer, Martha was the second, and Billy's the first. So Joan was about health, Martha about, who's the foodie, sure, hidden gems, and then Billy is about exploring. So if I go up here, right, and instead of salad campaign, if I want to add like I had before fun, but I could add like I could do fun again. So like a fun salad campaign, which doesn't make much sense, but I'll just show you how it works. So like, fun salads. So maybe these salads have, cool names or whatnot. We could say like with cool names. GitHub Copilot, it's making fun suggestions, but so if I run that, I execute my index search, and then I run it. And now Martha's first, right? So this is like a real live example of how these vectors change based on those descriptions. So Martha was about discovering hidden gems in the food industry. So just by adding fun salad campaign with cool names, right? That that gets
Fun salads around the world.
Oh, what's up?
Fun salads from around the world.
Yep. Oh yeah, we can try that. All right, fun salad campaign from around the world. Let's see. Oh, still put Billy last.
All right, it's probably right.
Yeah. But yeah. So I mean, here's a good example, and kind of the way that we we would circumvent, like, so the more complex and accurate this description is, the better the search is, right? With the influencers, and of course, our influencer descriptions are a little bit more complex past, just what they like to do and stuff. But just that was a good example. And just a demo of semantic search using like a vector storage database. Cool. So I guess you guys, any questions on this? I can go to.
I have a question that could, maybe the students are thinking. So one thing, and maybe a little bit also how you got started. So there's a lot of these libraries and APIs that require some kind of subscription. Do you have any advice on how they could start cheap to experiment with some of these tools and before they would raise the level and start having to invest money in it?
Yes. So great, great suggestion. So yes, I will say, so everything that I've demoed right here, and everything that I will demo this whole time, the only paid subscription that I have is with like ChatGPT, OpenAI, because that's really the engine behind how we do like how we run all of our stuff. But I will say, so like all of this vector database stuff, there's no subscription for vector storage. You do have to pay, like there are open source vector storage databases, but so there's other ones like that are, as you increase data size, like you eventually will have to pay for that storage. But there are many different, like if you just search, free open source vector storage database, you'll have a whole list of items will pop up. But then your comment on like the AI or so the like OpenAI and using ChatGPT. So yes, so it's like $20 a month to use, like to get an API key, and then you have to pay per token, I believe, and it's relatively cheap. So like I think like we're running this just about around the clock, and our cost per month is around like $35-$40, which isn't crazy. But there are open source options. I think Claude has an open source API that you can use, and the beauty of LangChain is they have a way to use Claude within their infrastructure. So that's a free option, and I'm sure that there's more. I think like Hugging Face might have some free ones. I don't know, Evan, if you.
Yeah, and I was just going to say, just into kind of more of the discussion of, entrepreneurship, I think, one of the really exciting things about the time that we're in right now is that these emerging technologies are, really lowering the barrier to entry. Jordan and I started all of our companies with no money, and you're really able to go, quite a distance with no investment. And then, like you said, $20 a month for ChatGPT plus, I think it's worth it for everybody, even if you're just using it personally. But like you said, we're running round the clock, usage of our dev keys, and we're spending about $35 or so a month. And then all of this other stuff is, free to use, free to get started with. And so really, it's really exciting because you no longer need, like Jordan said, $100 million to train your own LLM. You can kind of piggyback off of these tools that already exist. And for tools, even if, you do need like a $0 cost, there are solutions like Claude. And if you want to reach out to us as well, we'll kind of put our information in this. We can include some additional tools that we find that, kind of will, get you started, without any kind of capital.
What's the question?
Yeah. So so I have a question about calculating Euclidean distance. So let's say if I put the same parameter, I run the same line twice, and using the same parameter, is it gonna give me the same Euclidean distance?
I'm so sorry. When you say same parameter, you mean? Wait, let me go back to my notebook.
So
It's deterministic. There's no.
Yes.
You have a given input, you get the same output.
Yes, the algorithm is, yes, exactly. It is deterministic. So that demo that I showed doesn't use any. It doesn't use it. It uses like AI and like. Doesn't really use AI in terms of like traditional methods, but it does like through semantic search, which is used by AI. So like there was nothing like stochastic about that process in specific.
if that is the case, then let's say you're looking for some specific, let's say like fun salad campaign. Since we all have like a different opinion about fun, and AI has kind of just like this monotonous decision about what is fun. Then would that kind of affect what we're
And has never actually had fun. As far as we know, AI never had fun. Never experienced fun.
Yeah, so that's a good question. So the fun, like that would be encoded semantically. So like ChatGPT might not understand fun, but it knows like the definition of fun. But like what I'll say is, that was like a very, much more simpler implementation. The more information that you give it, like, so I would probably add, like fun stuff, like I would add more description, because when people are using when businesses are using our platform to enter details about the campaign, it's much more specific. So we try to limit the possibility of us relying on AI to like, determine what is fun is in terms of like giving us the output. It's a little bit more structure, and having influencers define their characteristics and businesses defining what they want.
And it goes beyond even just like salad usually as well. Like our platform is based on, it's campaign based. So usually, we're running either an event or it's a specific promotion, right? So it might be like, I'm doing a St. Patrick's Day party at a location, or I'm running a promotion for my, half pound signature like chicken thigh. And then they're going to go through, they're going to put their website, they're going to put like the details about that. They're going to put in a lot more information that we're going to build this, entire kind of description around it that kind of feeds the search. So it isn't, so ambiguous.
And what is your business model? Do you pay by search, or do you have just a subscription and they can do as much as they want with your?
Yeah, so our business model is, so it's campaign based, and so for example, we'll say Joe's Chicken comes in and they want to do their signature chicken sandwich, and they want to run a $5,000 campaign to promote their new sandwich. So what we do is we take care of the campaign like the same way you would with like a Facebook ads or a Google ads. You create that campaign as Joe's Chicken, and you say, here's my signature chicken campaign. I'm going to put in $5,000, and our algorithm is going to say, okay, great. For that, you can get 6 influencers at for that $5,000, and so we do a percentage of spend. Essentially, is the way that our model works. So it's not a subscription. It's free to essentially log in, get started, build a campaign. The only cost comes when that influencer connection is made. So basically, a percentage of that total campaign cost is reallocated back as kind of our commission for the networking. And then I will say as well, kind of more detailed into our platform is, once the connection's made, it's all handled directly through our app, right? So influencers have an app, they get the detailed description, requirements, everything from the business inside their app. They upload the piece of content that they film for the business right into our app. Businesses can review it on the web portal. They can, say, I want changes to that. I either approve it. That'll go directly back to the influencer's app on their phone, where they can either, make those changes, resubmit the content, or they say, great, I've been accepted. I'll paste the link to the final post, and they're paid directly through the app. So contracting is handled, payments handled, communications all handled without, the business's intervention. So that's kind of, in terms of, further streamlining the business processes beyond just the AI is that it's, sorry, go ahead.
You're offering the company is connecting with the influencer. They don't know exactly who they are right now, but they're coming to an agreement on what money is what the business is going to be paying the influencer, and then you take a cut of that essentially, right? Or the business
exactly. And so what they have the business has the option, right? So with our semantic search, we say, here's the influencers that match, and they can take a look and say, okay, great, these influencers match, kind of my brand identity, who I, would want to match my business with. But essentially, they're setting up that, say they put $5,000, we can say, great, you're going to reach, 200,000 people with that $5,000 based off of, the influencers reach, their connections, their network. And so, they're not necessarily saying, okay, I want to pay, Jimmy, $1,000 out of that 5,000. We have a more, robust algorithm in place, which, determines what that influencer is worth for their reach, what their engagement rate looks like. And we're auto calculating that. So we can say, with that $5,000, you can maximize reach with these influencers who best match your thing. And then it's a kind of a hands-off campaign. Like when you go ahead and say, I'm going to run a Facebook ad, you kind of let it run through its duration of that campaign. It's the same. We've implemented the same system into the influencer marketing ecosphere.
Is there a risk of them connecting with the influencer outside of your app?
There is, right? And so, that's part of our, privacy policy or terms and conditions, that when they both sign up is, communication should be handled, through our app. The benefit of our app is that if a business wants to go and connect with an influencer outside of our app, it's significantly more complicated, right? And so, if they want to do, contracting, they want to do payment, they want to do negotiations, they can do that by DMing them or emailing them or whatever. They need to put a person in place to manage that processes. We kind of, circumnavigate that with the ease of use. And so, when a business comes on, they can say, great, I'm going to run my campaign and, I'm just going to do this. And as well, when they go and contact influencers, and this is a problem that we've talked to a lot of restaurateurs and business owners about, is you don't know what the price that they're going to charge is, right? So an influencer with 100,000 followers could say, I cost $10,000. Where is, maybe they don't have a good engagement. Maybe they bought their followers. And that's things that we have, when we have a computer vision model, tracking them, tracking performance, creating those engagement metrics. And so, we kind of, our value prop is, ease of use and kind of a better experience for the business and for the influencer in terms of, just kind of ease of communication, payment, contracting, that whole thing.
And you get the money from the influencer or the business?
The business. So the business pays in, and then we pay out for the influencer.
Okay. And the influencer can build a profile for free?
Exactly, right. And so we have a mobile app that's available for influencers. And so, one of the things too is, there's a chicken and the egg problem, right? In terms of, hey, there needs to be enough businesses to support influencers. There needs to be enough influencers to support businesses. That's the problem that any of these influencer marketing platforms have had, think Upfluence, what we've done is we actually built a platform for influencers first. So we built a suite of AI tools as well on our mobile app that influencers can use for free, performance tracking on their accounts, AI tools like caption writers and script writers, so that they actually have a free mobile application that kind of assists in their content creation and monitoring that also has this marketplace attached to it where, offers will populate.
Very cool.
Yep. And that's the idea of Markata. And so, these other kind of applications like Jordan's about to show here, we have a company called To Something where we're actually helping businesses as well implement, some more of these emerging technologies into their processes, kind of help streamline and make more efficiencies. And so I'll let Jordan, this is a fun one here with a really cool UI. And I'll let Jordan take it away.
Yeah, this is the fun UI I was talking about. I'm not UI UX guy, but so pretty much what this is it's just a way for us. The goal for this would be to do it in an app, in something you could use on your phone. But just we were thinking, Evan and I are, big fans of Twitter, trying to use it to there's a very big business presence there, technological presence, a lot of cutting edge news comes out on it. So in an effort to try to build our following, right? We were thinking why can't we just create like an AI that can help summarize key features? And I'll say the biggest problem that I have with AI in generating unique content is AI doesn't take an opinion. AI does not, it won't think for itself in the sense that if I wanted to have a hot take on something, it won't natively do that, right? So that was something that we found, through kind of experimenting, and that's not the kind of content that people want to see, right? If someone sees, they don't really want to be they don't want broad high level content. So we tried to create a bot that can make good tweets and stuff with unique content. So there's just a few commands, and I don't know if we'll have time to go into how it all works, but it uses the LangChain to do everything that you're seeing right here and call the correct function. So we have a particular function which can research the web, add key phrases, write the tweet and then fine tune the tweet, which I'll demo here quickly. So the example I'm going to give right now is around. I know I'm not sure if you guys saw, but Apple recently announced that in 2024 they're looking to include RCS into their chat messaging, which is good so that when talking with Android phones we won't have hopefully the super grainy pixelated images and so on. So that's going to be the essence of the tweet that I add. So what I would do is I would say, I wanted to, so this is also an optional command, but I wanted to add the key phrases. Oops. I was talking about my typing speed and now I can't type. But I want to add the key phrases like Apple, RCS. I'll just add those two for now and I submit the content. You can see down here, this is the LLM, executing. So I have a prompt. So every time I say something, there's a prompt that's included. So I said, add the key phrases Apple and RCS. And what it does is it goes in and it calls my function add trending phrases, right? That's a function I defined using LangChain. And it knows, okay, now I have to add trending phrases, finish the chain, right? So it executed, confident that it worked. it would be cool if it talked back and said something else, but for now it's just you tell it what to do and it does it. So now I wanted to say like add the opinion that that Apple, including RCS, will increase their market share. Right? And the logic behind this is, if they add RCS, the existing people that have Apple will be more excited because they can interact with Android. Maybe this prompts more people to be like, okay, Apple is now a better messenger. So that's my opinion that I wanted to. That's like the essence, right? That's the core of the tweet that I wanted to include. You can see here now. It's called our add opinion function. Finish the chain. So now the next thing, and this is kind of where it gets a little bit more exciting and gets a little bit more abstract, is I want to say now find supporting information. Find supporting information about the key features involved with Apple and RCS. Right. So now what it's going to do is it's going to go in, and this one's going to take a little bit longer, but is it still going? Okay, cool. Yeah. So right. So here's the first step, right? I passed this through a prompt, right? My prompt is generate. We want to generate an internet query to find the supporting information. As an output of that prompt, it said, okay, it's going to look up on Google benefits of Apple, including RCS for market share, right? It found 2 websites, right? So, right, the first website is why does Apple not support RCS? The second one is why should Apple support RCS? So what it's going to do is it's going to go to these websites. It's going to download the content from those websites, and it's going to summarize the information. So you can see here, right, it finished. So it went through. So query added, web page is summarized. So, it looks like it didn't get to that website, but the second website looks like it found information. Cool. So now I want to say, good, it found some information. Now if I wanted to write the tweet, now it'll go through, it'll think, it's going to create the tweet, and it's going to output. Right here, it looks like it has the information. It's thinking, right? So this is the prompt that I passed it through. So I will say, like, these prompts are, they're a little complex and they take a little bit more time. And there's been a lot of fine tuning. And when people say like prompt engineering, it's really just changing a lot of words to figure out which one has the greatest impact on the output. But then, here as a result, right here we have a 3-thread tweet. So we could say like Apple's. I mean, we don't have to read through it all together, but we have it here. Actually, I'll paste it in the chat. Maybe that would be more helpful if you guys want to read it instead of reading it from my screen. But this is like a direct output from our API. And what we might do then is fine tune it. So I could be like, hey, fine tune the tweet to sound or to rhyme. Let's see if it works. I don't know. Is that how you spell rhyme? I think so.
Good enough. It'll figure it out.
Cool. So now if I said fine tune the tweet, we want it to rhyme. I don't know if it'll work, but I think you guys kind of get the idea, and we can fine tune it and take a more direct approach, use different language, and so on and so forth. And this whole application, unfortunately, we don't have enough time to really dive into it, but it uses those LangChain decorators. Oh wow, it did rhyme. Apple's hesitation, a cause for frustration. This is great. Let me paste this in the chat too, if you guys are interested. Cool. So this is kind of like, like a tweet bot writer, and this is just a very simple application, right? This could be abstracted. It could attach to an API that, publishes the tweet. Like, it could be a whole hands-off operation. It could query the Twitter API to find, trending items and make tweets about those things. Like, opportunities applications here are huge. But wanted to get that demo in because it's fun and it's something that we use, or at least I use it for now. We're trying to get Evan access.
I need my access.
So it's gate blocked by me, but here's just simple application of using LangChain, custom prompting, custom functions to kind of do something pretty cool, we think.
And it's a good business model. Make a social media app that's only usable by humans.
Yeah, we can make a whole business model around that. Good idea. Let's but yeah, so that's kind of our whole demo here, everything that we covered. So I think I'll kick it off to Evan here. If you want to cover the last.
Yeah, I know we're over time, so we'll just wrap this up real quick here. I hope this was helpful to everybody. We were, recent Stony Brook students. We're engineering this company with no money, right? So, as a bootstrapping entrepreneur, these emerging technologies are really allowing us to kind of break into the market, to really build these businesses at scale and penetrate the market against major competitors, especially in the realm of AI. I think this is one of the greatest opportunities we've ever had, bigger than the internet, bigger than any kind of technological advancement we've had. It's going to change everything. And so, I think it's really exciting. We're right at the forefront of it. You're not too late yet to learn it. It's a really great time for entrepreneurs. So we'll just kind of finish up here. I know that, going into the spring, a lot of you have, the opportunity to take an internship for credit. We have now done 2 semesters of internships. We have an MBA team working with us now. We had SUNY Plattsburgh students working with us over the summer. And so we do have a few different internships available if people are interested in coming to learn with us, at whatever capacity that is, learning more about this, getting involved in the business, especially as we are growing this company. We will distribute this to Richard to get out to the rest of y'all. So I'll just quickly, you kind of skip over to the next slide here, Jordan. So I think we're over time, let everyone kind of get out of here. But yeah, please connect with us. We're very open to, helping entrepreneurs and students in any way that we can. And so, don't hesitate to reach out. Here's our emails below. Those are our Twitter handles. We do post a lot of the content, everything that we kind of talked about today. As we're learning things, we are, updating, kind of our followers on all these different things, LangChain, UI, UX on my side, design, AI advancements, ChatGPT, and all that. So thank you all so much for having us here today. We really appreciate your time and the ability to kind of share what we've been working on and, where we think everything is kind of going. So yeah, if there's any questions or anything, feel free to, hit us now, but, please connect with us. Happy to continue to help.
Question? One quick question. Do you accept faculty as interns? It's very exciting what you're doing, and I think you opened the door for all of us in maybe pursuing some of these technologies. I learned a lot, with some of those tools that you were discussing at the beginning that I will personally look into.
Yeah, there are a lot of wonderful opportunities, especially when business students work closely with engineering, computer scientists, etc. So it's this type of environment we're supposed to create and foster. And another thing I want to